again in other places. When the machine was originally designed, the intent was 25 cryo modules, 4 passes. The cryo modules came in expensive, so they cut the number of cryo modules to 20 in each LINAC and increased the number of passes from 4 to 5. The beam will still see 100 cryo modules, it just sees sort of 5 passes instead of 4. Made the magnet system more complicated, a little more expensive, but it saved a lot of money in our shooting of the RF. So the net was we still made the budget. But the tunnel was already designed and under construction. So we ended up with 5 empty slots. And so what you see here is what you probably didn't see between the cryo modules. So between these pair of cryo modules, you have a couple of focusing magnets, and a couple of steering magnets to keep the beam on center in the beam pipe. With the beam position monitor, it tells us where the beam is. So there are 4 electrodes in here, and we sense we get signals from those 4 electrodes, and by adding and subtracting those signals, we can tell where the beam is in X and Y. And then we have a focusing magnet, just like a flashlight beam diverges, but you can put a spherical lens and focus it back down. Here we have to use electromagnets to charge particles. The focusing is a bit more complicated, but you can again have the beam diverge, get focused, diverge, get focused in both planes with these magnets. There are not many of them in the LINAC because you've got to have space for the cryo modules. But the other thing is that in the LINAC you have 5 different energies, and you can only set the focusing for one of them. You basically have to set the focusing for the lowest energy beam, but that means the upper higher energy beams are just not that well focused. So when you get past the spreader, past the point where we separate the 5 beams out again so that each is its own beam type, beam path, then we have a lot of these regular. We've got a dozen of them in the first 60 meters, and then 32 of them around each arc to keep the beam under control, oscillating in size, but keep it net at about 1/10 of a millimeter.